Hey everyone! Today, we're diving into the fascinating world of neural machine translation, or NMT, and exploring a technique called backtranslation. But we're not just scratching the surface, we're going deep into a new approach called end-to-end backtranslation. So, what exactly is neural machine translation? Simply put, it's using neural networks to automatically translate text from one language to another. Think Google Translate, but powered by some seriously clever AI. Supervised learning algorithms in NMT have shown outstanding performance but perform well if there is a large amount of bilingual corpus. Now, NMT models are incredibly powerful, but they have a big appetite for data. They need massive amounts of paired examples, sentences in one language alongside their accurate translations in another. The problem? These bilingual corpora are expensive and time-consuming to create, especially for less common language pairs. Imagine trying to train a translator for English and Klingon. Good luck finding enough training data. Unlike bilingual corpus, a monolingual corpus is easy to collect. That's where backtranslation comes in. It's a clever way to bootstrap our NMT models using readily available monolingual data, tons of text in just one language. The core idea is this: we take a sentence in, say, German, and use a pre-trained, but maybe not perfect, German to English translation model to translate it into English. This creates a synthetic English-German pair, where the English is a bit noisy. We then use this synthetic data to train an English-to-German model. It's like learning by trying to explain something you only kind of understand. You often end up understanding it better. For example, let's say we have the German sentence,
Das Wetter ist heute schön.
Our German-to-English model might translate it as, the weather is nice today maybe. It's not perfect, but it's close enough. We now use the weather is nice today maybe paired with Das Wetter ist heute schön to train our English-to-German model. Traditional backtranslation often involves training these translation models separately. This works, but it's not ideal. It's like having two people working on a project but not being able to directly communicate. Things can get lost in translation. That's where end-to-end backtranslation comes in. The goal is to train both the forward, e.g., German to English, and backward, English to German, translation models simultaneously, allowing them to learn from each other in a much more direct and efficient way. Think of it as a pair of dancers learning to move together, constantly adjusting to each other's movements. However, there's a technical challenge. Neural networks learn through a process called backpropagation, which relies on gradients. Standard translation models produce discrete sentences, and the non-differentiable latent sentence makes the backpropagation impossible to train the inference model. It's difficult to directly backpropagate through discrete outputs. Imagine trying to adjust the knobs on a soundboard when you can't hear the music in real time. This is where things get really interesting. The researchers in this paper propose a clever solution called the Categorical Reparameterization Trick, or CRT. Without getting too deep into the math, the CRT essentially smooths out the discrete sentence, making it differentiable. This allows the gradient to flow freely between the two NMT models, enabling true end-to-end training. Think of it like taking a pixelated image and applying a blurring filter. The original image is still there, but the edges are softened, making it easier to work with. In our case, the CRT smooths out the discrete sentence, allowing for a smoother learning process. What are the benefits of this approach? Well, the experiments in the paper show that end-to-end backtranslation with CRT leads to significant improvements in translation quality compared to traditional methods. The models learn faster, generalize better, and produce more fluent and accurate translations. The fast computation, controllable gradient, and flexible output are benefits in the E2EBT training framework. This has huge implications for making machine translation even better, especially for languages where training data is scarce. It brings us closer to a world where communication across language barriers is seamless and effortless. So, that's end-to-end backtranslation with the categorical reparameterization trick in a nutshell. It's a complex topic, but hopefully, this video has given you a better understanding of how it works and why it's so important. Thanks for watching, and don't forget to like and subscribe for more explorations into the world of AI and machine learning. Let me know in the comments if you have questions.